Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. Today, I'm joined by my co-host,
Ben Wilson. I work at Databricks designing stuff for really smart people to implement.
Nice. And today we have a guest named Nick Schrock. He started his career as a software engineer at Microsoft, then worked at a couple smaller organizations before joining Facebook. And then after a short 8-year stint, he founded Dagster, a cloud-native pipeline orchestrator that includes lineage, observability, and high testability. And he's also the co-creator of GraphQL, an open-source data query and manipulation language for APIs. So, Nick, I was playing around with Dagster and really love the simplicity and the power that you get out of the box. So was there a project or a pain point that originated this idea, or did you just say one day, I want to build this?
It was pretty much one day I just want to build this, I would say. The story is that, I left Facebook in 2017 and I was figuring out what to do next. And I was talking to all sorts of companies inside and outside the Valley about what their biggest technical liabilities were, kind of in an open-minded sort of way. And this notion of data ML infrastructure kept on coming up over and over and over again. Companies of all vintages, all sizes. And when I dug into it, I like to say I found the biggest mismatch between the criticality and complexity of a domain and the tools and processes to support that domain that I've ever seen in my entire career. So the only analogous thing in my experience was web development, say 2008 to 2010. Before the browsers were good, before React, before GraphQL, before TypeScript, before all that stuff. Like there's engineers were building these like extraordinary complex web apps on substandard frameworks and technologies, and it was just a complete nightmare. And if you look at the front end full web app ecosystem, and you fast forward in time to today, it is completely and wholly unrecognizable in a good way. And I think most importantly, it's become a true discipline. It is really transformational. So when I was looking at this in like 2018, 2017, data engineering in particular was like in this state for sure. And I think it's still in this state largely. There's a long way to go. So, I was adjacent to these problems at Facebook, but at Facebook, I worked in the mainline application stack. So, GraphQL kind of came out of a bunch of work internally to build our internal object model and a higher level kind of API to query the data at Facebook. So I was kind of intimately involved with that, and I would call it data infrastructure adjacent. But as I was looking into this space, I was immediately attracted to the orchestration layer. I like to think about the projects I like to work on have a few common properties generally. One, engineers in pain using like incredibly slow workflows. They're using abstractions that don't make sense. It makes me like fundamentally very upset, actually, and angry to see that, which is, it's not the most wholesome motivation, but it is what it is. Because like it seems like the universe is like unordered, and we could like fix it just by like having better ideas. Another thing I'm really attracted to is a problem that matters. And one of the things about data pipelining, data pipeline is the core data infrastructure, in my opinion. And the assets that are produced by these data pipelines power dashboards, which like inform like nearly all decision making in modern organizations, or they power ML systems which do automated decision making, and increasingly more and more so. And the fact that like no one really understood what their data systems were doing, they were terrified to change them. Like there was like very little confidence and trust in the data. And these are the things that determine whether you get mortgages or not. So it's like an incredibly important foundation of society run by millions of developers and engineers. So it's like a really important problem. I also like having like a novel technical solution, which I think software-defined assets qualifies for that, which is core abstraction of Dagster. And then last is a strategic point of leverage. So if you know about in the organization, So GraphQL had this property where it's kind of this like middle tier layer of software that manages all the interactions between all clients and all servers in a system. So you could, it effectively is this like intermediate layer that provides an enormous point of leverage. Similarly, I believe the orchestration layer has similar properties to that. The orchestration layer invokes every computational runtime, in turn touches every single storage system. Every practitioner who is putting a data asset into production has to interact with it at some level because all data comes from somewhere and goes somewhere. So properly conceived, I believe the orchestration layer is this like incredibly powerful point of leverage to build a generalized control plane for a data platform. And I came to that conclusion very quickly when I kind of looked at this. So that was kind of like I know that was a long-winded answer, but that's kind of where it all came from. And then I started digging in, and the rest is history, as I say.
I've got a follow-on question about that. From your unique perspective as being somebody who has worked on establishing a standard that is used ubiquitously in industry because it's so awesome, what do you think the tipping point is for both large and small companies that are trying to solve a problem in-house in whatever way they can? How much of that has to happen before a bunch of people get together and say, let's establish an open standard that people can conform to, publish it, and then build that middle layer to simplify the world?
So you're kind of asking like, at what point do you standardize? Or I'm trying to tease apart the question a bit. Like,
what have you seen? Like, is that impetus for somebody like you and your team to say, GraphQL solves a ton of our problems. Let's open source this so everybody can benefit from it.
Yeah, I can tell the GraphQL story. I think that is a good one. So GraphQL is built very quickly. Effectively, I conceived of the idea in February 2012. And then we built it and shipped it in 3 months to power the feed of our mobile app, which is kind of the most high stakes surface at the time in our applications, because it's going to drive most of our usage and revenue. So we had to make a lot of decisions very quickly, but it got extremely wide adoption very quickly as well. Because like in the Facebook app, feed is like the ultimate point of leverage, because every team wants to inject feed stories in order to get distribution. And that's how they do a good job. So once you kind of capture feed, the entire rest of the app follows. So we actually had an interesting internal problem in that we got adoption too quickly internally, and we're kind of falling behind because the underlying technical reality, as well as downward pressure from Zuck to move everything to native. He'd like go down to the timeline and be like, why isn't profile native yet? And then they'd like freak out and want to build GraphQL endpoints in the native app to do it. So we, in effect, we had seen the success of React, which was inspirational. So the CEO of Dagster Labs, who I would say a close collaborator of mine, is Pete Hunt. He's the co-creator of React. And if you think GraphQL is a universal standard, React is like an order of magnitude bigger, I think. So we saw that, and we also wanted to open source a front end library called Relay, which is kind of like React and GraphQL have a baby, and it looks like Relay. It's kind of like this like GraphQL specific front end framework that also mashes up React. So, I think that was kind of pushed us to it. And I talked to my co-creator Lee about it, and I was like, we should open source something. And as I like to say, convincing Lee to do something is a process. And then he comes back like a couple of weeks later after I've talked to him about 5 times. He's like, I'm I'm into this open sourcing thing, but you know what we should do? We should standardize it, write a document about it, and not really open source any software. And I'm like, and we should also redesign everything. And I'm like, what are you talking about? Like I was talking about like open sourcing the thing we had. And then like, you know, I do a lecture on second system effect and all this stuff. Right. But it turns out Lee's a genius. And he's right. And he kind of like came back. Like, I don't know if it was like ayahuasca or something, but he came back from the mountain with this like perfectly formed idea of like what the system should look like. And it took a while for me to get there on some of the issues, and I had some feedback, but you know, we had kind of built up this intellectual capital over years, using the system. And I think Lee had incredibly good instincts on what the broader developer population needs because of the experience with React, because React was unique in that all the other Facebook technologies were all like internally facing, whereas React had this huge user base. So I think anyone on the React team had much better instincts on what a broader developer population needed. And then, you know, that spec, which Lee largely wrote and I participated in, has really stood the test of time. And now it's evolving slowly in an incremental, like structured way as part of a process. So I think that we were able to develop on the GraphQL side a bunch of intellectual capital and then kind of marry it with some of the experience that the React team had to kind of build something that like was pretty good out of the box, and good enough where people could build their own implementations in their own programming languages without oversight from us, which by the way, I thought would never happen. I was like, who's gonna, like, we're expecting all these people to build runtimes in all these programming languages? And Lee's like, sure, why not? It's fun. And I'm like, what are you talking? Like, this is crazy. It's not going to work. It completely worked. I was completely wrong. So so that's the GraphQL story. I think you know, on the Dagster side of things, it's more of a challenge because we're building it out in the open. And I don't think it's at the point of maturity yet where we could write a document to standardize it and then like it would be good for all of time. It's just not, you know, we're not quite there yet. And yeah, I think that's one of the challenges we face, to be, you know, perfectly transparent. You know, but I think we're much closer than we were, say, 2 years ago.
Question from, or sorry, go ahead, Ben.
No, I was just going to say, to add on to that, the way you phrased it sounded like you guys don't have that figured out, but I just wanted to add that nobody has that figured out as like a universal standard, because it's pretty much impossible to do until you get the generators of data and the computation platforms to agree on at least some direction of how the industry would want to move.
That's right.
Instead of just new tools coming out all the time, a lot of them proprietary, people saying, I can make a ton of money off of this, building this closed system that doesn't interface with anything or provides this API endpoint that could be archaic or so cutting edge that nobody really knows what to do with it. And people are like, well, now I need to build a connector to this and I need to support this, instead of that whole, you know, like, hey, let's think about this intermediate layer where we can all agree to a conceptualized idea of how to handle data movement from place to place.
Yeah, that's right. No, it's and I think the other question is like, what are you being opinionated on versus not, right? Like our version of a standard is not standardizing on storage format like Parquet, or standardizing on in-memory format like Arrow, or a computational runtime, or SQL, because, you know, despite the, you know, this has been kind of the era of the SQL maxis, but you know, you can't capture all compute encoded in SQL. And so then what are you standardizing on? And and so that's where I think this like notion of this kind of middle layer, which is agnostic to compute platform and storage system, but allows you to structure the complexity of your data pipelines in a way that provides a homogeneous layer over underlying heterogeneity, is kind of the path forward. And that feels a lot like, I guess I'm probably presuming too much knowledge of GraphQL for the audience, but it kind of feels, in that way, it also feels like GraphQL, where GraphQL is like this query language, that is effectively a front end for an application server. And through that, you can orchestrate all sorts of backend interactions with microservices or any sort of backend, and it all appears as like this standardized format, even though beneath it there's like perhaps stunning heterogeneity, and it kind of actually just like organizes the complexity that's going on. And that's why I think the direction needs to go for data platforms.
Yeah, because otherwise, I mean, speaking as somebody who has somewhat limited knowledge of front-end development based on my current job, but we do own a front end. We do own, myself and other people primarily do the back end stuff for that.
Yeah.
But when you're trying to develop a React app that's connecting to your backend services, you need to know, where is my data? What interface do I need for that? What is that access layer looking like? And when you start adding more and more features onto your front end, you're now no longer communicating with a single interface.
That's right.
You're saying, hey, each of these features could have independent access, paradigms to the backend storage layer, which just explodes your code complexity.
Yep.
And then when something changes, like, oh, we need to migrate our schema. How many places in your code do you now have to update and test and make sure that things don't blow up? It's like, it just trashes developer productivity. And what I used to before doing what I do now was doing what Michael does now. So a lot of data engineering stuff with customers, and can confirm nobody has this figured out. You talk to any company, regardless of size, and you ask them, for this ML model that you're about to train, where'd your data come from? Like, really, where did it come from? Do you know what backend source system generated this that went into that RDBMS table, which then went into this ETL pipeline, which then went into the data warehouse, which now goes into your query layer? They're just like, I don't know, this team just puts the data there.
Yep. Yeah, and then most organizations, when they try to reconstruct that, they try to often do it, there's kind of like different gradations, right? There's like a manual spreadsheet driven process where they just like document everything. And then the second they make that, it's out of date. No one can trust it. Then you maybe bring in a cataloging system, right? And there's some automation there, but it's still post hoc observation of everything that's happened. And it ends up being like full of junk and like doesn't feel like a true system of record in most places we see it, right? Whereas, what we believe is that you have to have lineage and provenance effectively come for free as part of the programming model. Yep. And that's why we firmly believe, and that has to go across technologies, right? Because like, as you know, you go to a client and they almost certainly probably have both Databricks as an account, but also one of the cloud data warehouses. Like, they coexist everywhere. So you need a system that at minimum spans those two things. And then there's just all sorts of garbage in every single like data in every platform. By garbage, I mean well-constructed technology. Totally thoughtfully adopted and constructed. No, but like, I mean, I've been there too. I'm not just being glib. So like, that's why we think it's so exciting to view the orchestrator as not just this like narrow thing which runs something every day, but as a system of record for the structured data assets of your organization, and having that system of record simply be an output of the programming model that we use. So yeah, that's kind of what we end up doing. It kind of ends up feeling more like a standard for how you construct data platforms at companies. Because our line is that every company has a data platform. It's a question of whether they explicitly acknowledge it or not. And that platform is like inevitably multi-technology, multi-tool, multi-persona. Because data drives and is consumed by all sorts of people and all sorts of use cases across every org.
Yeah, Ben and I were chatting about a topic that's related, which is, how are you deciding? So the pitch for Dax, or for basically a central orchestration layer, is you have lineage, and that comes for free, as you mentioned. Can you provide some examples of shiny things that you guys decided not to build?
Shiny things that we decided not to build.
And why?
Well, we very much view ourselves as a data engineering toolkit built for data and ML engineers who embrace software engineering best practices. So we're not in the business of drag and drop tooling. We're not in the business of capturing things that are outside source control, for example. We're not in the business of kind of integrating tons of manual workflows into our cataloging tool, for example. On the ML side, which is what this podcast is about, in general, I find that, ML ops is generally expressed in the world as it being its own silo of tooling. And I don't think that makes sense. I think it's a layer. There should be ML ops specific tools that are built on top of a generalized data engineering platform. And so that means that you do your pipelining in the base layer, i.e. in Dagster or something else. But then things like model serving and hyper-specific ML tools should be the province of other things. We're not particularly interested in building a complicated, ML. We were talking about in the leading up to podcast, ML flow-esque experiment tracking layer. I think that's a whole another company. I don't know how many engineers work on ML flow. There's got to be a lot of features in there.
On the open source side, it ranges from 8 to 20
right
on a given quarter. On the Databricks side, I think we're up around 100, 115.
Right. Yeah, so that's like a Series D company.
And that's just working on the ML side of stuff at Databricks, which is the smallest department.
Yeah, but it's a good question, Michael. In terms of, I think we have to fight our own vices of having our eyes being bigger than our stomach. But for example, we think of ourselves as we do have a cataloging capability. But we think of it about a layer of cataloging that provides kind of bare bones, targeted experiences related to operational matters. But then there's other data catalogs which are way more sophisticated and incorporate both, manually inputted metadata and processes around that, and very complex web app, and that is not in our wheelhouse. What we do is we empower the engineers to write code, which ends up producing metadata, which is displayed coherently in a cataloging platform, which is available both as a web app on our system, but also, we want downstream consumers to be able to consume that, so that they don't have to reconstruct lineage on their side, and they can actually focus on going up the stack in the cataloging space, which I think is actually a win-win for both participants.
Yeah, exactly. I'm currently working on a project that's a Azure Databricks to GCP Databricks migration, and we're trying to get lineage to inform how to move resources from one cloud to another. And working backwards is just hell. We're parsing audit logs, we're basically getting as creative as we can. So it makes a lot of sense that if you start with a really robust programmatically driven orchestration layer that gives you lineage and everything is sort of hard coded together, it's the right way to do it, and it makes things so much easier.
That's right. I think it was actually Armbruster. Michael Armbruster is one of the vaunted engineers at your company. He was. I remember talking to him a few years ago, and he was like, we're finding a lot of success getting people on streaming, Spark streaming, even if they don't use it for streaming. And I'm like, what are you talking about? He's like, well, streaming gives a much more is much more constrained in terms of lineage that you have to do, because you have to declaratively say that B is downstream from A. So even if you just actually run just effectively just run batch through the streaming process, well, you end up with better outcomes because it's a more constrained programming environment. So I thought that was a pretty interesting comment. I don't know how much that's played out over the years, but
we have an entire product line devoted exactly to that. It's called DLT, Delta Live Tables, and it is exactly this.
Right.
So micro batch transactions. So using streaming as a batch service, just constraining it to say, where did I leave off? Where's my latest token that I'm going to be processing? Process that through the system and record metadata about it. Say, how many records did I pass through? And what was my throughput rate? And a bunch of other metadata. But yeah, like customers jumped on that. Customers that you would never imagine would be interested in spinning up a Kafka service and connecting to it for real-time streaming. They don't need it. But just that lineage.
Yep.
Yeah, it makes sense. I'm really excited about the prospect, and I've been having conversations internally with another maintainer of MLflow about this whole data-centric concept of ML, exactly as you said it. Like, hey, it's a service that is data-centric. It happens to produce objects or functions that operate on that. The ML people and data scientists call them models, but at the end of the day, it's a function. It's taking data, it's operating on it, and it outputs something. We can call it whatever we want, but they're all functions. Even Gen AI, whatever you're doing, it's a function. And the thing that is really impactful on how the behavior of that function works is that data, and about knowing how to reconstruct it reliably, how to migrate it between systems. You do all this work in dev, and you're like, hey, a lot of data scientists take a Parquet file or a CSV file to generate their features, and then they kick it off to an ML engineer for deployment. And now they have to spend 10 days, like a full sprint, or maybe 6 sprints to take that script code and convert it into something that's deployable. To build that, like, where do I get my features from? Like, where did you get this data from? It's a cool data set that you use for training, but I have no idea where this data is. But having that lineage from dev to say, here's the 18 source tables that constructed this data set. And then you can just take that definition and say, okay, deploying to staging now, because all of those data sources are mapped in staging. Let's make sure this runs. Does it retrain? Does it work? Okay, we're good. Ship to prod. The only way to do something like that is using a universal standard, I think.
Yep, totally.
Yeah, and I think this also reflects a trend that we've been seeing, or at least I personally have been seeing. We were chatting with Praveen Paratosh on episode 116, and he was mentioning this new sort of concept in ML, which is actually not that new, but it's data engineering focused. And they had essentially a hackathon where, holding the model constant, you're allowed to do whatever you want to the data. How can you minimize model accuracy? So make the worst possible model. You can throw like crazy feature engineering at it, but the cross-validation steps and the model itself will remain unchanged. And this sort of reverse engineering of the process of model building, it really shows how the data are, like, that's the valuable thing. Like, yes, linear regression versus a decision tree, that matters. But if you have bad data, it's really tough to make a good prediction consistently.
Yeah, so all the values in I think still in all these systems, all the values in the data pipelining, and the quality and understandability of data. And I think it's actually going to play out in Gen AI too. Like, the foundational models are getting commoditized. So, what the value added thing in specific companies or apps is going to be is their ability to understand their own proprietary data and, introduce that into the Gen AI process, whether that be via RAG or some other methodology. I think I didn't fully read the article, or I saw it go by. The Databricks' Matej Zaharia, your CTO, pushed out something about compound applications, which I think is getting at this, that these Gen AI apps will end up being, it's good. The LLM component should be more thought of a computing primitive that you can use to assemble into a coherent application rather than just like complete magical, LLM consumes something and something good happens. Like that's not the way it's going to work. Like it's going to take thoughtfulness. And let me put it this way: I think the elimination of software engineers has been wildly overblown. But of course, I'm going to say that because I'm a software engineer. But I happen to believe it's true.
The only thing that I've seen with this Gen AI renaissance, we're just hiring more people. You need more people to wrangle these things. And the thing that's come up most recently for me that I've started thinking about is the application of first principles to all of the new hype. And the ones that are successful, because I'm doing evaluations now, like we've mentioned before, about tracing for these Gen AI apps for
Right.
MLflow. There's a lot of ways to collect logs, like a lot. Every big tech company out there over the last 3-4 decades has had to do some sort of instrumentation on what data is being passed around as like message traffic, and knowing, hey, what is my REST endpoint actually generating, and how do I capture failure rates, and how do I instrument that? And then over decades of working with that stuff, people said, let's just do a standard here. Let's come up with a standard. Everybody interfaces with this, and you see how quickly something like that gets adopted. All the big tech companies are like, yes, our services integrate with this. This is the way. If you're a user of our platform, you get this for free.
Right.
And it'll also connect to these 30 services that all subscribe to the standard as well. So from an end user applied perspective, where you're trying to use tooling, having everything on that standard, you don't even have to worry about it. But then when we're talking about the new hype coming up, you get a new generation of developers that are all working on this, that not all of them have a lot of history and experience and knowledge about how standards were developed over time. They're like, hey, I've got a problem. I need to log information about this. And you look at these engines that are interfacing with Gen AI to build applications like the RAG type stuff, and you can see who's been there, done that before, that has then started this open source project. You're like, oh yeah, this is the next Meta engineer, or this is somebody from Google. And you look at their history, and a lot of times I get to chat with them on one-on-ones and stuff. And you're like, oh, I see why you subscribe to the standard. And you did a really good job with this. This is awesome. And they're like, why would I do anything else? But then you get somebody who's new, who's never been through that pain. And it's just like, well, my users say I need logging, so I'm going to write my own instrumentation.
Right.
And you look at the structure of it, and you're like, what are you doing here? Like, there's no parent-child relationship between these events. Like, yeah, you're collecting all of the records of stuff. You don't have any way of disambiguating when these events occurred, though. It's just a collection of data of like, hey, here's the inputs and outputs from the system and from the user. What happened when? And how do I visualize this so I can debug it? Because there's no relationship here. There's no DAG that you've created. In the system, there's a DAG because it's temporal events that happen and child processes kick off. But it's just interesting to me, and I want to know your take on that. As somebody who's worked in standards and has thought through all these problems and has invented this stuff, when you see new generations of people building tooling, and they should be doing it a certain way because you went through that and suffered through what happens when that doesn't happen. What are your thoughts about stuff like that?
Well, I guess I'm less beholden to standards you might think. Kind of one of the legends of like, you might like, now meta engineers have a good reputation and like they come in and they're the ones who know what to do. But in 2009, that was not our reputation. It's a bunch of script kiddies writing PHP. Like, who are these clowns? And then our open source stuff, when React was initially introduced to the JavaScript community, it was like rejected on impact because like we were like, it had a XML-S syntax, which was like embedded in JavaScript and then precompiled, or people call it transpilation, but same thing. And it was just like, people were like, you do not like, that's not what we do. We've, separation of concern, blah, 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 blah. And it was a big fight to kind of persuade the market that, no, actually, this is the right way of doing things. And a similar thing happened with GraphQL and Relay and all this. We were fighting model view controller orthodoxy. So we explicitly were like, oh, that standard is bad. We should not do that, right? Because the whole thing of like separating, like you must separate your views from your data. And we're kind of like, well, if you're displaying something, there's a implicit coupling between fetching that data. Like you can't pretend like it's not there. So yes, we agree with separating concerns, but actually the entire industry is conceiving of separating the wrong concerns, because the problem that they were fighting was that people would like, linear loop fetch from a database and then produce HTML strings. And the problem there is not that the view and the data logic is commingled, is that you're coupling the string generation with synchronous calls to a database, which is like very bad. And so what you want actually is like requirements for view and data co-located in a centralized coordinating mechanism that can make the fetching efficient. So, anyway, another example here is like, for some reason beyond understanding, like I'm like a huge microservices hater. And that has become like standard wisdom, best practice. And like, and I think it's applied to startups or small organizations. It should be the tool of last resort, not a first resort. But if you have someone that comes in from Amazon or Google, right, they'll come and be like, well, this is the way we did it, so this is the way you should do it. And I would say that the new grad out of college who then says like, aren't we just building a web server, is the one who's correct.
Right.
So I guess I always check myself when I have the instinct to do copious beard stroking and wag my finger at the kind of beginner's mindset, because I think often people are grasping at something that it makes intuitive sense, and there should be a good reason why they can't do it. So yeah, I'm, at least in the engineering organizations that I'm a leader in, I'm definitely willing to tolerate probably a little more chaos than most. I think sometimes I go too far that way, and should kind of like impose a little more. So I guess, yeah, that is, I mean, just, it always comes back to first principles thinking. Like, you're like, because I think a lot of people reach for the familiar because like, oh, we did it here. Yep. But then you have to have the discipline to apply that idea to a new context, which is like, okay, what is a problem that's actually solved? How relevant is it to this new context? Are all the ideas applicable? Are only some of them? Or is it complete hogwash? So it's like experience grounded in experience, but always context aware judgment.
Can you elaborate on what a first principle is to you? I know that's a very open-ended and potentially seemingly obvious question, but I think there's a lot of nuance in how you approach defining a first principle and how you go about getting them.
That is a very good question, and I'm frustrated with myself that I don't have a good answer off the top of my head for it. I guess I have to derive the first principles on the fly here. But yeah, like a first principle. Here's one, for example. If you're building a framework, a good first principle is the open-closed principle, which says that it should be open for pluggability or modification, but it should be closed to modification, but open to extension or pluggability. So you should be like, have a principled thinking about like, this is what's fixed, this is what's pluggable, and let's figure out, given the constraints of the system that we want to impose, how we maximize flexibility for our developers. So I think like that's an example of a first principle. But yeah, I would need to like, I think, ruminate and go on a hike and really cogitate about more broad. That one's top of mind because like came up internally a couple weeks ago. I don't know. How does does that strike you as first principles thinking? I guess the other thing is like what the process is of first principles thinking rather than an instance of it. And to me, that's like more about like trying always to strip away jargon and really talk about at the core what you're doing and the trade-offs that you're doing it with. And I really respect a lot of, I think leaders who are good at first principles thinking generally end up communicating in jargon-free ways. And so that's kind of another indication, like whether you like them or not, like I know like talking about Elon is like a potentially triggering event, but Elon or Jobs or some of these like venerated figures in tech, I think what's interesting about them, if you listen to them talk, there's like zero jargon.
Mm-hmm.
Like they speak in very plain spoken words about highly technical subjects that my mother could understand, but largely, which is remarkable. Like kind of like the generic, like kind of like the normal leaders kind of end up speaking in this highly jargoned way of speaking. I probably do it all the time, not being self-aware. But if you can, like, I think you're engaging in first principles thinking if you can boil down the trade-offs you're making into fairly jargon-free language. Is like another process here. So these aren't very good. These are more like ruminations rather than a fully constructed thought. But
nice, yeah. So the origin of that question is a lot of my work involves saying, do you really want to do it that way and why? And suggesting a solution that is sort of circumnavigates the problem and makes everything just simpler and better. That's a key part of the resident solutions architect role. And I know Ben has been doing this for years. So Ben, I was curious how you think about sort of cutting through the noise and finding the correct answer.
There is no correct answer. There's just answers that are better than others. But really, my guiding first principle is always do your homework. If you're writing code, particularly exactly as Nick just said, framework development, that used to be a huge pet peeve of mine when I was like in the field or talking to companies, when people's first reaction is, we need an ETL framework on Databricks, which is an ETL framework. It's like Spark is a framework for processing distributed data. You want to build an interface on top of that you're basically building a custom DML in Python that interacts with PySpark, which interacts with Scala, which interacts with the JVM. It drove me nuts because nobody is sitting there saying, what do we actually need to do with our data? What are the things that we need to do to make sure that the translations that we're doing or transformations that we're doing to our data between our source system where we're loading from and where we're writing to, are those correct? Are we validating that our data is not corrupted or missing or flawed in some way? Because those are the things that burned me when I worked for companies in the past. I had owned some ML ETL pipeline that I wrote, usually poorly, and just randomly someday, this column just starts producing all the same number. And you're like, you find out about it 3 days later or something when your production monitoring that you set up for how well this model's performing, like, why did everything just start going crazy? What's going on? You go and dig in, waste an entire day of work until you find out, oh, this column for some reason, this data set is broken. Go talk to the front end devs who generate this field that goes into the, into the database that gets synced over into the data warehouse. And they're like, oh yeah, sorry, we had a regression. Should have told you about that. But that whole process of building stuff that would break and not using tools that could have let me know about that sooner, or allowed me to know that the transformations or manipulations that I'm doing on data wouldn't be causing production problems. That I learned a lot from that, but that all goes down and boils down to that whole concept of, well, I'm going to build a framework to interface with this thing, when what you really should be thinking about is, does this already exist? Can I just use something that somebody has built and it works really well and adapt it to this use case? And then after exhausting, 8 or 10 answers to that question of doing your research and saying, no, this doesn't exist, or this doesn't meet my needs, and only then building something. So that homework aspect of like, what do I actually need to solve here, is so critical. And it's part of everything that we do on our team in engineering now requires designs like that, where you show that you've done your homework.
Yeah, that makes sense. Another high-level question for both of you. So we've talked a lot about the past and how ETL has sucked, how lineage has been painful, and how having the central orchestration layer is valuable. What are the next 3 to 5 to 10 years of data engineering going to look like? What are going to be the big innovations? What are going to be the big new technologies that make our lives a lot easier?
That's a big question. I might give answers that are not satisfactory, because I still think there's so much low-hanging fruit on basic nuts and bolts thing in this domain. Like, there still isn't, it still is not standard, I think, for there to be a green button that turns green when you know that your PR into a data platform is not going to break anything. Like, most companies that I know, or nearly all of them, do not have the tools and processes in place to do that, to both even get to that state where you're very confident that code you're about to merge and deploy is not going to break anything, and also getting to that state in a reasonable, productive way. So literally, if we get to that state in 3 years, where broad swaths of the industry can now live in that world, it sounds like the most boring pedestrian thing. But I think that level of productivity at an org is transformational, because productivity for an engineer is not just the ability to complete tasks at a certain rate. Productivity is about reducing the complexity you have to hold in your head, so you can start to think bigger and compound on top of your system, rather than just being drowning in all the fires that you're lighting along the way. So I think a great 3-year time frame goal is to get every practitioner who's working on a data platform, and not even like across the industry, make this even possible, so that they feel like they're in a productive workflow and can develop software quickly and with confidence. And I think there's a bunch of stuff that needs to happen in order to make that work. Like, I'm inspired by like DuckDB on this front, where you can kind of like run the same data warehouse code on your laptop in the cloud or in your web browser. That last fact is bananas to me, by the way. And then tools like Modal, which is a startup by Eric Bernhardsen, that makes it very fast to upload new code to a cloud and run it kind of as fast as you can on your laptop. I think that type of stuff is great for ML workflows. I like to think that Dagster can have a part to play there, because like, we're an orchestrator that really thinks about the full end-to-end development process, rather than just think of it as like a deploy-only thing that runs stuff on a schedule. We're more of a programming model. So yeah, I mean, everyone, again, makes me an old fogey maybe, and everyone's so hot on, the Gen AI capabilities, and they're incredible. But I still think there's so much value in the data pipelining and building the core assets to drive all this stuff. And the developer workflows and the engineering workflows are just still so broken. They are so broken. So that's like one thing, which is just like, if we get this basic bread and butter stuff right, the world is a whole lot better. Kind of the next, after that, the other thing I'm excited about is we call it the so-called single pane of glass in the data platform. So is there actually a trusted source of truth where you can understand, observe, and operate your data platform without it, and all due respect to the company you guys work for, without it just being one vertically integrated stack deployed by one company? Because I think that's like one way the world ends up, which is that there's people who are on the Snowflake stack, and there's people on the Databricks stack, or there's people on the Microsoft stack, and then they have to like choose what stack they're on early in their careers. And like anything, there'll be tools of different quality at different layers of the stack, and there aren't portable skills between them, and that's like a very sad world. Like to me, that's like going back in time to a world where like you had to like decide when you're 25, like I'm a Microsoft person, no, I'm an Oracle person, and then you're kind of stuck in this one proprietary stack for a while. There's a lot of pot of gold at the end of the rainbow for companies that do that, so I don't begrudge them for doing that. I think Databricks should build its own catalog and its own orchestrator and all this stuff because it makes sense for them to do that. But what I'm really looking forward to, say in like a 5-year time frame, is a world of much more, we'll call it ordered heterogeneity, where there is heterogeneity at the stores, the compute layer, and all sorts of tooling, but it's bound. Oh, did my mic drop again? I'm gesticulating too much. I almost hit my mic. And we it's very trite. And so I apologize in advance, but there is sort of like an iPhone moment to be had, I think, with the right, obviously I think it's Dagster, but with the right technology where you can kind of like in the iPhone, the thing that's cool about it is that it presents this like very ordered layer of software that provides lots of guarantees in user experience, but you can still install thousands of apps on it. There's still like a vast array of capabilities. And if we can get a toolkit into companies' hands where their data platform can feel like that, where it's like, okay, like we can bring in a different technology. Like, we were using Snowflake at first for analytics, but we want to bring Databricks in for ML capabilities, right? Bring that back while still providing a unified experience to all your stakeholders is like a very exciting future. We're very far away from that, but I do think what needs to happen. Lastly, you got me going here, so I guess I came up with some good ideas. The other thing I'm really excited about is the merging of software and data engineering. So meaning that one of our lines that we use now is that while data engineering is software engineering, it's a software engineering subspecialty. I think the other way should and will occur, which is that data is so instrumental to the way that every software application is written, meaning like you need to have analytics to understand what's going on. There's going to be more ML capabilities so that data feeds in ML models, which feeds back into the behavior of the system. That this whole like silo between software and data engineering should disappear. And instead, you should have people who know enough about data engineering sprinkled around all your product teams, so it becomes much more of a merged discipline. From basic things all the way from like, hey, if you add a logging field, let's have a system in place so you don't break your data warehouse. Right? So there's like basic levels of just like, in retrospect, it's gonna be like, that's the way that worked. It's like wantonly reckless that like at any point, like an application developer could like just break the data warehouse. Like it's, I swore there. It's crazy. But there's more profound things too. Like I was very inspired. I was talking to engineering leader at Watershed, and it's a company that does climate change, carbon credit compliance for other companies, and it's basically a data pipelining product. Because like the companies upload this data, in a structured format. They do transformations on it to produce reports and all sorts of stuff. But they have all of their application developers writing writing data pipelines in effect. So they have one code base. It's all JavaScript. So their front end, their back end is all JavaScript, and the business logic of their data pipelines is also in JS. And they do their kind of distributed compute on DuckDB. It's like Banana is an awesome stack. I was like so inspired when I talked to them. But I think what's cool about that is they structured their system so that every software engineer is accountable for the kind of data pipelining consequences of what they do. And they can actually share business logic between, like, they can literally run the same code in the web app and in their data pipelines, which I think is awesome. They obviously have to do a bunch of work in order to make that work well and build a bunch of custom infrastructure. But so I guess those are the three things that I would be excited for, which I think will happen on some long time frame. So, getting basic dev flow working across companies' data platforms, single pane of glass so that there's a coherent experience across a heterogeneous tool set, and then the merging of software and data engineering.
What do you think is standing between Dagster and the iPhone moment?
That is a good question. I still think that, I still think we have to work on incremental adaptability and progressive disclosure of complexity in our system. One of the challenges of building out in the open is that you need to move forward and experiment with ideas and test stuff. But the moment you do that, then you have a public API, you have support forever. So there's a lot of one-way doors here. So that's been a challenge through the project for sure. And I think as a result, we kind of have a lot of cruft and things that we can't undo, but we have to move forward. And I think and we're well aware of these problems and totally acknowledge that the feedback we get on this is correct. But I think like one of our biggest challenges is like making it so that both in greenfield cases, it feels smoother to get the system going, as well as being able to land at companies that have existing data platforms and making that process feel less risky and more incremental is like very critical.
Okay. I'm following, I think. And just out of curiosity, what are some of those core one-way doors that you've walked through and can't go back?
I mean, you can always go back. And some of it's like not very profound, but like if you like choose a stupid name for something, right? It's very easy to do. Naming is hard. And then 6 months later you decide that the name is dumb. Now it's like a whole thing. You have to deprecate, roll it out to your community. You have to get people to migrate their code if you want to eliminate it, yada, yada, yada. So it's just a general notion of public API server. This is what I'm thinking about. Like web apps are easy to change. You just push. you push it, the UI reforms. People are annoyed for a bit, and then they move on because they haven't written code and infrastructure that binds against it. But building an infrastructure product is challenging in that way. Especially if you make strict guarantees on backwards compat, which we do, like you are not allowed to break people's code.
Yeah,
that makes a lot of sense.
So okay. Maybe on a major version release that you tell everybody 6 months ahead of time, this is coming, by the way.
Right.
We have the same thing with MLflow. It's like you have to do back compatibility testing for everything. So nightly builds, we're testing other like tools that we integrate with, like libraries. We're testing their main branch on GitHub. We're pulling it every night, testing along with all of our other version tests just for that reason.
Right.
And it's a lot of infrastructure you have to build. I mean, a lot of people look at a tool like that and you're like, well, yeah, there's a couple 100,000 lines of code in here, but then you look in CI, you're like, whoa, that's a lot of tests. Like, yep.
Yeah.
And a lot of those are dynamically created too.
Yeah. Well, to be clear, like I actually think Databricks is pretty inspirational on this front, insofar as like they were building out in the open and they went from RDDs to data frames to Spark SQL, and it was kind of like a layer cake in a way. But now I doubt that much net new code is being written against RDDs, for example. I mean, probably some, but like it's not like. But I assume that the runtime still, you know, will support older code. I don't know what the version break has been, but on that, but
Spark 4 is a foundational shift.
Okay.
Yeah. So that's a big, you won't easily be able to interface with RDDs anymore.
Okay. I mean,
You
it's been like 15 years or something. So it seems like a reasonable, that's a pretty good run, I think, for supporting a legacy technology.
Yeah.
Is Spark 4 like specialized for Photon or something? Or
yeah, a lot of backend compiled C code and a new abstraction layer with basically multi-user process isolation. So it's very safe environment where you can be like, hey, 30 people can log into the same cluster. You can't see what anybody else is doing. And we'll dynamically allocate resources on the cluster level to make sure that everybody can execute their code in a reasonable amount of time.
Got it.
But yeah, that took years to go through Apache PMC, committee voting, people saying, well, I still really like this language interface like this way, and eventually convincing a huge group of people to say, yes, this is the way forward.
Yeah, I think people dump open source projects into Apache way too early into their life cycle. I think it's like what you do if you want to deliberately slow it down. It's like that CIA manual, which is like, how do you like slow down companies? It's like demand on committees and blah, blah, blah. Like one of them would be an open source software, like get it into Apache. Once something like you want to like things to stabilize quite a bit before you do that, because I think it does reduce innovation.
Yes, could not agree more, and that's why we didn't do that with MLflow.
Yeah,
Linux Foundation's great, having their support. Apache. We're good.
Yeah, I mean, if it's the only way to exfiltrate the IP, if that's what you want to do, then it is what it is. But it should be much like microservices, the tool of last resort. And also with GraphQL, we've had a very positive experience with the Linux Foundation.
Yes. Yeah, they're awesome.
Yep.
Cool. So
once I found out that if we put GraphQL on Apache, they're like, well, you have to use Jira. I'm like, what are you talking about? Like, bye.
Yeah, there's a lot of requirements in their contract. Where like, why are we doing it this way? Like,
why do you care about our task management system? Like, are you kidding me? Anyway, all due respect, I know there's different strokes for different folks.
Some big projects in there. There's a lot of also dead projects in there, but a lot of important things.
Yeah. So before we say anything too controversial, I think we should wrap. I know we're also coming up on time. So this was a really interesting episode. I have like 7 topics that I would like to talk about for multiple hours each, but we don't have that kind of time. So I'll quickly summarize some things that stood out to me. If you're looking for business opportunities, you should look for pain, importance, sometimes novel technology, and then if there's a central point of leverage, that's an advantage as well. On the first principles side, don't look down upon the beginner's mindset. Typically, fresh perspectives are really valuable. And then also, you should be really context aware and go deep into the problem space. So if you really understand something, you can typically operate with first principles more easily. And then a good example of true understanding is be able to explain it like you're 5 or to a 5-year-old, excuse me. So don't use jargon and be able to match different levels of complexity based on your audience. And then
5-year-old might be a high bar.
Yes, you're right.
Let's say a
yeah. What's a good age, Nick?
I would say someone who's like a 20-year-old, say.
Okay, cool.
Mm.
Or your grandma.
Right.
And then regarding the future, there's still a lot of low-hanging fruit in the data engineering orchestration world. That said, global quality checks and having a central source of truth, sort of that glass pane, and then borrowing techniques from software to increase reliability. All three of these things are going to be very valuable in the next 3, 5, 10 years. So, Nick, if people want to learn more about you, your companies, your projects, where should they go?
Yeah, so Dagster.io is Dagster's kind of homepage, and we didn't actually talk about Dagster that much, but
I
it's
noticed.
kind of the it's a place where you go to build data pipelines and a data orchestration platform, but it is very targeted towards software and ML engineers who embrace software engineering best practices. And kind of the core notion is that instead of thinking in tasks, you should actually think about the data assets that you're producing out of the pipeline, and then lots of things fall out from that, including increased developer productivity. Your organization gets way more context on your data, and increased trust. So, very exciting times.
Yeah, and it's an awesome tool. So yeah, a lot of our listeners are highly technical and typically marry the software engineering, data engineering, and ML components. So I'm sure this will be of interest to all of them. So yeah, great episode. Until next time, it's been Michael Burke and my co-host
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.